Good evening, Manas. Start after 3 minutes. Okay, so we can start. Hope I am loud and clear. If I am not audible, then you can tell me either in chat box or you can unmute yourself. So my name is Shutran Sadhavan. I am a PhD student of IIT Bombay. I am your facilitator for the fifth weekly interactive session of Water Governance and Economics course offered by NPTEL. Okay, so this is the last week of August. After this, the all the 5 sessions of the August will be covered, and hopefully all of you have attended the last interactive session, uh, which was offered by the course instructor himself, Dr. Tiwari of IIT Kharagpur. So actually, the recording link is provided here. If you have not watched it yet, you can watch it in YouTube. And it was a really very informative and interactive session. So where Sad clarified many important concepts. So I highly recommend everyone to watch this if you have not watched it yet. But if you have watched it, and also if you have gone through the last week lectures, so the problems, those things we will discuss in this class, and also the MCQs, those we will be discussing in this class. Everything will be clear to you. Okay, so welcome and good evening. And also, I think one or two more lectures will be organized by NPTEL, where you will be able to directly interact with sir. I also recommend you to keep an eye in your uh, email ID, so where the announcement will be there. So I also highly recommend you to lively interact with him. in the latter couple of sessions. Okay. So today we will start with a problem. It is as follows. An industrial outfall is releasing 4.32 megaliters per day effluent to a river having flow rate of 12 meter cube per second. The background BOD level in the river is 0 and BOD in the wastewater is 12,050 milligram per liter. The permissible BOD limit in the river water is 10 milligram per liter. Actually, it is not a fresh problem. It is a recap of a previous problem because I saw that at the last of the lecture number 15, some problem was discussed and the solution was not complete solution was not given, but the concept of that problem is a bit advanced than the problem we discussed in last class. So I this problem is just a recap so that you will be able to understand the other problem that I will be discussing second to this problem today. Okay, so in this problem, actually, we have solved this problem in the last class. So where assuming the instantaneous mixing at the discharge point, the BOD of the river water at the discharge point, you will have to calculate in milligram per liter, and the percentage BOD removal that is required for the industrial wastewater to ensure the BOD of the river water sustains within the permissible limit even at the discharge point. You will have to calculate the percentage. So actually in these two problems the solution method we followed was as follows. So first the data, I'll quickly recap this problem. Actually, I will not tell you to solve the problems. So the data given was the effluent flow which was being discharged at the river. We converted it from MLD to meter cube per second. Then the effluent BOD was given. Then the river flow was given as 12 meter cube per second. River background BOD, if it is not given and it is given as 0, then we can take it as null. Then the BOD at discharge point we calculated as flow rate of effluent into BOD of effluent plus flow rate of river into BOD of river divided by total flow rate, that is effluent plus river. So in this way, meter cube per second got cancelled out, and in milligram per liter, it was the BOD at the discharge point. But we wanted to restrict the river BOD because of ecological and other reasons to be as 10 milligram per liter. So the maximum BOD in terms of effluent, it was because 10 milligram per liter is in terms of the river water. This is the river total flow rate, river plus effluent. So this is the total amount of pollutant present in the river water. Now we are dividing it with the effluent flow rate to get the BOD in terms of the effluent flow rate. So it came out to be 2410 milligram per liter. And hence the percentage treatment that we calculated in the problem was as follows. So this was the effluent BOD that is to be maintained at the discharge point before discharging that effluent to the river water. So we subtracted that from the effluent BOD. This is the amount of BOD that needs to be treated divided by the initial BOD that was present in the effluent, and this was the percentage of treatment. Okay, so now today a bit complicated problem we will solve together. So let's see how many people have joined. This was just a recap, okay? Not much. Okay, so I think you are able to follow. This was the actually the recap of the one of the previous problems we solved in last to last class. So today we'll solve a bit advanced problem which was discussed at the end of the lecture number 15. So I actually modified the data a bit because sir expected you to solve the problem by yourself. Uh, and if you are not you still not able to solve the problem, you can post it in the discussion forum where sir will provide you the complete solution. Okay, so we'll solve a similar problem, but it is a bit advanced than the previous one. So it is as follows. Uh, 22 megaliters or million liters per day of wastewater of a town is being released in a river of flow rate same as before, 12 meter per meter cube per second, where water travels for a day before next withdrawal point. Now here it is stated as the water is discharged at a point and water is traveling from that point to another withdrawal point, and between those 2 points there is a gap of 24 hours. Okay, now the natural decay decreases BOD in the water following first order with a rate kinetics of 0.09 per day. These things actually needs to be clarified. I will clarify it in the coming slides. Okay, so if the influent BOD of the sewage stream is 2500 milligram per liter, what percentage removal is required before discharge in the river so that BOD at the withdrawal point doesn't increase above 11.5 milligram per liter? Okay, to solve the problem, I will not tell you to solve the problem. I will clarify the concept of first order rate kinetics uh, before solving the problem. So what is rate kinetics, what is natural decay and all, we will come into those concepts. So well enough so far. If you have any doubt, you can ask. You can unmute yourself or you can ask in the chat box. Okay. So now the concept of the decay kinetics. Okay. So let us assume BOD of an element of water is expressed as L suffix T, which is nothing but a function of time. So the thing is that there are certain aerobic bacteria, those are present in water. Okay, so those bacteria actually what they do, they naturally degrades the pollutants those are present in the water. So there is a natural decay or natural reduction in the amount of the pollutant those are present in the water. So that's why the BOD of the water changes with respect to time. That's why it is expressed as function of time. Okay. Now at time t equals to 0, let us assume the BOD of the same water element will be LT equals to L0. Now nth order of the decay means uh, Actually, the rate expression of the decay is expressed as minus dl by dt. So it is generally directly proportional to L to the power n. So nth order means the concentration of the pollutants or the BOD that is present in the water at that time. So it is to the power n. Nth order means that only. So the power actually is indicated by the nth order, and the rate expression is written as minus dl by dt. Why minus? Because the BOD decreases with time. Fair enough? Okay. So as it is directly proportional, so the rate expression will be minus dl as a function of time by dt equals to k into L to the power n, where k is a proportionality constant. Or if you are conversant enough, I think Donesh is you know well, because you are a postgraduate student. But many students, who, for the sake of recording, who are not conversant with plus two level of mathematics, who didn't have mathematics in the plus two level, they might have a bit difficulty in understanding the integration and everything. So the thing is that for their sake, they just have to remember the formula. And if any student who had plus two level mathematics in plus two level, then they will able to understand what is integration refers to. That is LT is expressed as the dt comes at the right hand side, and it is integrated from time 0 to time t, and equals to as the k is a constant, so it comes out of the integral sign, and integration is performed from 0 to t L to the power n dt. So for the zeroth order case, where the L to the power n, the power is 0, in that case actually the we have to put the n's value as 0. So L to the power 0 will be 1, and integration 0 to t, it will be simple. K is outside, this one is basically 1, and 0 to t integration comes to t. So for zeroth order case, the rate expression will be LD equals to minus KT. For first order case, the L to the power n comes to the left hand side, and after performing the integration, it comes out to be ln of L. If we put the values of t equals to 0, at t equals to 0, L is L0, and t equals to t, L is LT, then it becomes ln of LT minus ln of L0. That means ln of LT by L0, and right hand side remains the same, that is minus KT. For second order case, when n equals to 2, if you perform the integration, there are standard integration formulas in the plus 2 level. So it is actually L to the power n minus 1 divided by n minus 1, something like that. So actually n plus so standard formulas are there actually. So after putting those values there, so you will get this expression. If you know plus 2 level mathematics, then actually you will it will be very easier for you to understand this. If you don't know, just you have to remember the formula. For first order, it is like that: LT equals to minus KT. For sorry, for zeroth order, for first order it is the formula, for second order it is the formula. Just you have to remember the formula to solve the problem. Or if you have background and you know integration, then it is very easy. Then I am not going to the background of integration for this case. If somebody has any doubt or if discussion is required, then you can say. But otherwise, I mean, it is assumed that you know this things very well. Okay. So now for nth order kinetics, when n is not equals to 1, because if n becomes 1, the for first order case, this becomes the formula. If n is not equals to 1, that is the all other cases, 2 and onwards, 2, 3, 4, 5, 6, everything. So in those higher orders, 2 and higher, which are greater than 1, that is L to the power 1 minus n minus L0 to the power 1 minus n divided by 1 minus n equals to kt, where k is the proportionality constant, t is the time for which the water element is traveling from one place to other. As in our case, in our problem, the water is traveling from the discharge point to the next withdrawal point, and the time is given as 1 day or 24 hours. So for nth order, for other higher order, this is the formula. The L0 is the initial BOD and L is the final BOD after time t. If you know the initial BOD, you can calculate the final BOD. So after certain time, what will be the final BOD? So actually, this concept was not clear at the last of the last class when we solved the BOD problem. So that's why actually we are clarifying this. So if any doubt in understanding the decay kinetics of the BOD, because bacteria are present inside the water, so they are responsible for decrease in the BOD level because they are utilizing the oxygen and they are decreasing the BOD. So instantaneously there will not be any difference in BOD level, but after some time there will be decrease in the biological oxygen demand. That means because BOD is an indirect expression of the amount of biodegradable pollutants that is present inside the water. So amount of biodegradable pollutant will decrease over time. So that's why the following different order kinetics, some may be first order, some may be second order, some may be fractional order. Sometimes it may so happen that pollutants are decreasing, so there are some complex rate equation may be there. So with the help of that, BOD actually decreases with time. So in our case, it will be first order kinetics because it is mentioned so in the question that the decay of the BOD level in water follows first order kinetics. Now there are certain terms like BOD5, BOD3, from where this concept comes actually. So in the BOD testing methodology, there are basically BOD bottles in which you have to keep the pollutant water and you have to measure the dissolved oxygen. After 3 days or after 5 days, you have to again measure you have to open the BOD bottle and you have to again measure the dissolved oxygen content. There are BOD incubators actually within which the BOD bottles are kept for 3 or 5 days under certain temperature conditions uh, for the incubation to occur. So from where the 5 3 these concepts came actually during industrial revolution in United Kingdom, there are Thames and other rivers. So in the Manchester actually from the point of the discharge up to the point of the point where the uh, river water mixed with the ocean, it took 3 or 5 days, I think. That actually the residence time distribution or the water element actually stayed in the river for that long. So that's why actually from there actually the 3 or 5 days concept of BOD came. So they saw that the uh, from where the discharge of the pollutant is occurring in the river, from that point up to the point where the water is going to the or mixing into the ocean, the time required is 3 to 5 days. So when the river water is going to mix into the ocean water, the BOD present in the water, what is its condition? Whether it is permissible to uh, sustenance for the aquatic life, or it is harmful to them. So whether so natural decay is causing how much reduction of BOD in that river water. So from that industrial revolution time, so the concept of BOD 5 or 3 days came. So in the BOD bottle also, you have to keep the BOD the water for testing of BOD for 3 or 5 days. So from there actually BOD 3 or 5 concept came. Okay, so let's come back to the problem. So any doubts so far? I think not. Okay. So here we have to follow the first order kinetics, and we will return to our problem. So, and here it is seen as the first order rate kinetics is given as 0.009 per day. That means you have to see that what is the unit of T and what is the unit of this. That is the rate kinetics, that is the value of K. So this is 0.09 per day. If it is given in hours, then you have to divide it with 24 and convert it into day, or alternatively you can also put 24 here. So units is a very important thing, you have to keep it in mind while solving the problem. Okay, so now we will go to the solution. So I think you have understood the problem. So will you try yourself, because I have given you the rate equation for the first order. So I think should I give some time, or should I solve go with the solution? Will you try? Danesh or Jobin? Oh, I think we can proceed with the solution, because okay, because this type of problem you are solving for the first time, so it is not very easy because of the rate kinetics concept that is in the picture. Okay, so I think you have understood the problem. What they are asking, they are asking the same thing, that what percentage removal, that means after the discharge, what should be the treatment percentage. So before throwing that effluent water into the river, what percentage removal of BOD, or what BOD during treatment is required. So that is same thing they are asking, but here the data is a bit different, because they are telling the permissible BOD 11.5 milligram per liter. This BOD, they are telling that this is not at the discharge point. This they are stating it is at the withdrawal point. Discharge point is the upstream, and withdrawal point is at the downstream. Between the discharge point and the withdrawal point, the water travels for a day. So I think the difference of this problem with the previous problem you can understand. Okay, so I'll proceed with the solutions. So the data given are effluent flow, it is 22 mld, that is megaliter per day, which comes out to be 1 megaliter means 1000 meter cube, and if you convert day into second, it comes out to be 0.255 meter cube per second. Okay, So effluent BOD is 2500 milligram per liter. It is given in the question. And river water flow is 12 meter cube per second. You can imagine it as a T-like structure. So where the river water is flowing and the effluent is getting mixed in the water. So river water flow rate is 12, effluent flow rate is 0.255. Both the streams are getting mixed, and river BOD, that is the background BOD, it is not given in the question, so we are assuming it to be 0. Now the BOD at the discharge point at the T junction where the effluent is getting mixed with the river water, it is simple mass balance. It is effluent flow rate into effluent BOD plus river water flow rate into river water BOD divided by 12.255, that is the total flow rate of river plus effluent. So BOD is basically the concentration of the biodegradable pollutants present in the river water. If this is clear, then this mass balance you can also understand. C1 V1 plus C2 V2 equals to kind of that, equals to C3 V3. So V3 is V1 plus V2. With V3 you are dividing the entire thing. So you are getting the C3. That is a simple mass balance. BOD balance equation is nothing fancy. Okay. So the value after calculation comes out to be 52 milligram per liter. Okay. Now here the crux in this problem, it is stated as the natural decay decreases BOD in the water following fast order with a rate kinetics of 0.009 per day. So if you go back to the that is your rate equations, then you will see that in different cases the unit of K will be different. In zeroth order case, you can see there is L's unit and there is T's unit. So K's unit will be milligram per liter per day or second. So the unit of BOD divided by unit of time. So in first order case the rate unit of K will be just the inverse of the unit of time, as in our case it is given as day inverse or second inverse maybe. In case of second order, it will be liter per milligram per second, something like that, I think. Yes. So if you just compare the left hand side unit and right hand side unit, then you can get the unit of K. But the unit of K will be different in different cases. And by looking at the unit of K also, you can determine the order of the decay. That is, order of the decay may not be mentioned in the question. It may so happen just they are giving you the rate constant, and from the rate constant, it may so happen that you have to understand the order. I think the point is clear. So here in the question it is given, but even if it is not given as first order and just the K value is given, by looking at the unit of K also, you should understand the order of the decay kinetics. Another important thing is that not much higher order, that is third or fourth order will be maximum, not beyond that higher order will be given. Only zero first and second order are common in common cases. So if their power only one on the liter per milligram, then you will understand it is second order. It is more than one, then you will understand it is more than the second order. So which is not the case generally. In the problem, it will not be given. Not much higher order will be given. Only up to second order you can expect. Okay, so let's return to our solution. So the first order rate kinetics is given as 0.009 per day, as it is per day. So even if the first order is not stated in the question, you can understand that you have to follow the first order rate kinetics equation. Now it is stated as from the discharge point to the withdrawal point, the water travels for t equals to 1 day. Following the first order kinetics, at the next withdrawal point, the BOD will be L at t equals to 1, that is after 1 day, equals to L is represented as BOD at time t equals to 0, that is as at the discharge point, into e to the power minus kt. Uh, so L0 is the BOD at the discharge point, which we calculated as 52 milligram per liter. So we put that value here into e to the power, the Ks value is given, and the T is 1 day. So we put all those values here. I think it is clear so far. Okay. So after calculation, it came out to be 51.5 milligram per liter. What is this basically? 52 milligram per liter. So the thing is that this is the BOD at the discharge point. It is at the first T junction, and the withdrawal point is 1 day apart at the second T junction. The water element, depending on the speed of the river or the flow rate of the river, which is 1 day, the natural after the natural decay, the BOD decreases from 52 to 51.5 following first order kinetics. If it was zero order, if it was second order, then the value the would be reduced to something else, from 52 to something else. It is the first order. In case of first order, it is coming like this. Okay, so I think it is clear so far. Uh, so the question might be given like this way: river flow is given and river cross sectional area is given. From there, uh, uh, and also the distance between the two discharge points are given, but the time is not given. So from there, if you divide that river flow rate, volumetric flow rate, with the river's cross sectional area, then you can get the velocity of the river water. And if you divide the distance between the 2 points, that is the discharge point and withdrawal point, if you divide the distance with the velocity you calculated as an answer, you will get the value of the time. So here in this question the time is given, but it may be further, the problem may be further complicated like this. So the time may not be given. Instead, the distance between the 2 points and the uh, cross section of the river may be given. So you have to, or it may so happen that the velocity is given, so you have to calculate the volumetric flow rate. So it can be further complicated like that way, but not if you have understood, then it is not complex and simple. Okay, then I think it is clear up to this point. Now the calculated flow of BOD at the next withdrawal point will be 51.5 milligram per liter. We have calculated this. Now maximum allowed flow rate of BOD at the withdrawal point, it will be 11.5 milligram per liter. It is given in the question. So normally people are withdrawing water from that place, there the BOD must be reduced up to this level. Okay, so what is the treatment amount? The BOD to be treated to restrict the BOD at the withdrawal point uh, as 11.5 milligram. It will be 11.5. So, to correct it. Okay, so if from 51.5 we have to reduce the BOD up to 11.5, then the treatment amount will be simply 51.5 minus 11.5 equals to 40 milligrams per liter. Now we have to remember that this concentration is in terms of the total flow rate, that is 12.255. That means concentration into total volumetric flow rate gives you the total amount of pollutants that is present inside the water. This amount of pollutant you have to remove from the effluent water. So that's why you have to divide it with the effluent flow rate and convert the 40 milligram per liter in terms of the concentration of the effluent water. So this amount of concentration you have to remove from the effluent flow rate, that is 0.255 meter cube per second. I think you understood up to this thing. Why this fraction came into the picture, 12.255 divided by 0.255, because 40 milligram per liter treatment is in terms of the river water, but before the discharge of the effluent into the river water only you have to treat it. So you have to treat this amount of concentration of BOD, because it is present inside 0.255 meter cube per second of effluent, which will be treated in the effluent treatment plant before the discharge into the river. That's why we the term which is in respect to the river water effluent, river water BOD. So you converted the river water concentration in terms of the effluent water flow rate. And why this fraction is coming into the picture? Because there is no BOD present in the river water. The background BOD in the river water is 0. If the value of the uh, river water were not 0, or some value was given, the background BOD value, then this fraction would be complicated. It would not be very simple like this way. I think it is clear. I hope so. Okay. So the percent treatment that will be required in this case will be the treatment amount, which is 1925 milligram per liter, divided by the amount of original BOD that was present in the effluent into 100, which is 77% in our case. So I think the problem is clear to you. If you have any problem in understanding, then you can ask. The thing is that, do you want to say something, Jovin?
No, sir. No, sir.
Okay,
We understand.
okay. So the thing is that here, if the first order decay kinetics were not given, then from 52 to 51.5, this 52 to this 51.5, this amount of reduction would not have been there. So if the order, if the decay kinetics and everything, this data was not given in the question, then uh, more treatment would have been required. So it, instead of 77%, it would have come maybe 78 or 79, like that way. Because because of there is some natural decay is taking place along the flow of the river. So that's why the initial treatment of the water that is required in the inside the treatment plant before the discharge is less. I hope it is clear. Now we will move on to the next MCQ. Municipal water supply utility setup water tariff to charge its consumers for which of the following? Option A is water as the substance. Option B is water as the resource. C, water combining both as substance and the resource. And D is services incurred in delivery of water. So in case of municipal water supply setup, sometimes uh, consumers are charged for water. So they are charged for which of the following reasons? Uh, which of the following cases, four cases, municipality keep in mind while treating?
Sir, option D.
Okay, you are telling option D. Okay, we'll see the answer. I think it is correct. Uh, as two of you are there only, you can unmute yourself and talk. There is no need to type, or you can also type. Whichever way comfortable. So I think it is correct. We will see. I forgot the answer. So the explanation is a commodity has an economic value and is considered as service if it is delivered to consumers. So option D is correct. As municipality is just a public body. And whatever resource, water as a resource is basically a public property. So a public body cannot charge the public for its own property, public property, right? So they are not charging the water as a resource or as a substance, but municipality is incurring cost for the treatment of water because whatever form the water may be present in the nature, that may not be usable, directly usable by the public. So that's why they have to treat the water. For that reason, some chemicals, some capital cost, or some energy cost may be there, which the municipality has to recover. So that's why they are or the pumping cost is there also for supplying, and also for opening and closing valves. Some people might be employed, they have to be salaried. So for many reasons there are service charges which the municipality has to recover from the consumers. So that's why option D is correct, as you have correctly said. Okay. Now uh, from the below statements you have to identify which one is correct about water audit. So option one is water audit refers to the accounting of water, considering inputs, outputs, and losses. Option two is water audit also considers accounting of money in water utilities, covering income, expenditure, interests, and taxes. So what is water audit basically? It water audit is done keeping uh, water stewardship in mind. Water stewardship is basically responsible use of water. So what is the amount of water that is uh, being treated? What is the amount of water that is being lost? What is the unaccounted, which includes the theft and everything, uh, billed and unbilled water. So everything comes under the water audit. Uh, because water is a shared resource. It is not an, I mean, individual property. If some industry, uh, I mean, limitlessly withdraws water, then it will not be available for the public use, or for public use, the availability will face some difficulty. So that's why what audit is done. And so what you are telling, Jobin is telling option two. Um, Sorry. Okay. Uh, I think it will be option one, because okay, let's see. So explanation is accounting of money in water audit utilities covering expenditure, income, interests, and taxes isn't considered as water audit, because water audits only considers water as a resource, shared resource, or responsible utilization of the resource. So if there is no amount of water is left, there is no question of affordability. So the thing is that only in case of audit, audit is done in keeping the water stewardship in mind. That is the responsible use of water as a shared resource. So that's why uh, in our case, option A will be the correct statement. So audit only considered the mass balance, water in, water out, water lost, theft, accounted, unaccounted, billed, unbilled. But what is the tariffs? What are the taxes? What is the cost incurred in treating the water or supplying the water? Those things doesn't comes into the picture in case of water audit. But of course, these are important. In some other cases later, we will see that how the tariffs are uh, considered, and we will also solve some problems based on the water tariffs. Okay. So the next MCQ for you is the value derived from the existence of resource at a location is considered under option A is direct use value, option B is indirect use value, option C is non-use value, and option D is option value.
So option A.
Okay, direct use value, not telling. Okay, so we will see the explanation. Existence of a resource at a location but not brought into use is of non-use value. So our correct option will be option C. The thing is that uh, how let me tell you a bit analogous situation. For example, the cost of money, the value of money in a country, for example, like in India, is considered with respect to the amount of gold reserve. So if certain gold reserve is discovered, which is basically the public or the government property, then the value of money will increase. That means if one Singapore dollar means 60 rupees, then one Singapore dollar will be uh, let's say 55 rupees or 56 rupees, like that. That means the value of money is increasing by the just the mere existence of the resource that is present, but you are not using that resource. So in similarly, uh, In case of existence of water resource also, the value of a nation or of a state may increase, because in future, though that resource can be utilized as a let's say as a uh, for generating income for that state or for that country. So that's why inherently it is increasing the value, but presently that resource is not being exploited. Or let's say, if some country has some petroleum reserve, then even if it is not exploited, the international monetary organizations will be able to will consider that country to have some high credit value. They will give loan easily to that country because of its natural reserve, though the natural reserve is not digged and utilized by the public or any company. But the international company understand that they will be able to utilize that resource and generate money from that, because they don't have the infrastructure to do that. They can give loan to that company. Similarly, for water resource also, it will increase the inherent value, even it will increase the credibility of the nation or state that is holding that resource, though it is not utilized. So as it is not utilized, so it is non-use value, but still it is of some value. If it was utilized, or it is pumped and supplied to some places, and for that reason economic development is occurring, or certain such and such things, so then it would have been the direct use value. Okay, no issue, but because the concept of, I mean, it is not very easy concept, so you are encouraged to give answer, and it is not the sessions will not be marked. Okay. It is just for practice. So next MCQ is, market-based allocation of water resources is very effective for allocation to. Option A is basic human need. Option B is industrial demand. Option C is environmental flow, and option D is all of the above. Okay. Uh, Dhanesh is telling option D, all of the above. Okay. I don't remember its answer. Jobin is also telling me D. Okay. Go with the solution. The explanation is as follows. So market-based water is for commercial purpose, and so it is best available to meet industrial demand. The thing is that uh, for basic human need, uh, it is actually, you can generally understand it is different from market-based, and sometimes market-based allocation may exploit the environmental flow. So these two options will not come into the picture in case of market-based allocation of water resources. So option B, industrial demand, is the correct option here. Okay, the next MCQ is, contingent evaluation method may be used to estimate only use value of water, only non-use value of water, both use and non-use value of water, and neither use or nor non-use value of water. So what is basically contingent evaluation method? We'll come into that. So if you have seen the lectures, Jobin is both are telling. Okay, I have not told yet. Okay, we'll see what is contingent evaluation method. So it can be used, the contingent evaluation method can be used to estimate both use and non-use values, and it is the most widely used method for estimating the non-use values of water. So both use and non-use value of water here is important. Contingency means what? We'll see. So before that, one more MCQ. The value of water at a recreational site is based on number of trips people are willing to make at different cost, is considered under option A hedonic pricing method, option B benefit transfer method, option C averting behavior method, and option D is travel cost method. So I'll go with the explanation. We'll actually see that what is contingent based method, what is hedonic pricing method, what is benefit transfer method, averting behavior method, everything we'll see. But here it will be option D. So the travel cost method is used to estimate the value of recreational benefits generated by a resource. It assumes that the value of the site or its recreational services is reflected in how much people are willing to uh, pay to get there. So recreational site means where people travels. It is basically a value of water at a tourist spot. So that's why if people are willing to travel to up to that area and willing to pay the cost that is incurred for their transportation, then only the value of water at the recreational site uh, comes into the picture. So that's why if people are not willing to go there, then there is actually no value of the water. So that's why it is based on the travel cost method. Okay. So we will see what are the other methods, that is hedonic pricing method, benefit transfer method, and averting behavior method, and also the contingent method for water pricing. So I think we can discuss it after the break, or we may discuss the pricings terminologies. Then we can take up a 5 minutes break. Okay, so we'll discuss the methodologies first. So the contingent evaluation is a survey-based economic technique for the evaluation of non-market resources such as environmental preservation or the impact of externalities like pollution. In case of contingent situation, which is environmental calamity, pollution due to environmental or man-made causes, for whatever what will be the cost of the water resources that is present in such contingent condition. So the pricing which is based on such situations is called the contingent evaluation. Mm, the hedonic pricing is a model that identifies price factors according to the premise of the hedonic regression. It is also called as the hedonic demand theory. It is basically in economic terms. It is a revealed preference method for estimating demand or value. It decomposes the item being researched into its constituent characteristics and obtains estimates of the contributory value for each. The other two methods one of which is benefits transfer methodology, refers to the process of applying valuation results, functions, data, or models derived in one location or context, that is study site, or another one is policy sites. The data that is generated in the study site that is utilized to estimate the economics value of the ecosystem services in the policy sites, which is an alternative location or context. It is called the benefits transfer methodology, just like we do scale up studies in case setting up a plant, maybe water treatment or something else. That is called as the benefit transfer methodology. The hedonic pricing method basically is dependent on the economic theory. Uh, it is a regression based model. The contingent evaluation is a survey based model, or it is considered in contingent or emergency situations. This evaluation is a based on the statistical data. The benefit transfer methodology, it is something like a study done in one place, and the benefits or whatever the study results that is applied to the other place for determining the policy of water pricing there. And the last one is the averting behavior method, which refers to the actions taken to demand against environmental or other hazards, whether by reducing exposure to hazards or by mitigating adverse effects of exposure. So it is a bit similar to the contingency evaluation, but contingency evaluation is more statistical or survey based, which whereas aversing behavior method is not. But both is uh, actually dependent on the evaluation based on the contingent situations like environmental hazards or adverse effects of the exposure of hazardous chemicals to the environment. And this is contingency evaluation is more of environmental emergency situation, and averting behavior method is more related to the human behavioral pollution, that is related to the human behavioral conditions. So these are several water pricing methodologies. And travel cost methods is related to the recreational side. It is dependent on the people, how much they are willing to pay to to go from one place to the other place for travel and for recreational purposes, and how much they are willing to pay for the water. So the pricing is done at the recreational side based on the travel cost method. Okay, so I think the next problem we will discuss after taking a 5 minutes break. So actually, the whatever subsequent problems will come, that is basically based on the water pricing. Okay, so we can start at 7:15, I guess. We'll start at sharp 7:15. In the meantime, whatever we have discussed until now, if you have any query regarding that, or whatever chat discussed in the live interactive session last Thursday, if you are having any doubt or queries on that, you can tell me, I can discuss. Or else we'll meet at 7:15 or 16. এই বদের হাড়ি কি বলছে কয়ু? পড়াচ্ছি দেখতে পাচ্ছ না? মিউট করে তোমার সাথে কথা বলতো, রিয়াল কি হচ্ছে নাকি? হ্যাঁ, এটা ন্যাশনাল লেভেলে রেকর্ডিং হবে, সারা ভারতবর্ষের লোক দেখবে। অবশ্য ভারতবর্ষের দু একজন লোকই দেখবে, যাই হোক, দু একজন না, মানে ওই 10-12 জন দেখবে যারা কোর্সটা নিচ্ছে, কিন্তু যাই হোক তাও তো একটা ন্যাশনাল লেভেলের জিনিস, এরকম ইয়ার্কি করে কেউ? কত সিরিয়াসলি এটার জন্য আমি প্রিপেয়ার করি, কত ভয় হয় এটার জন্য। তুমি আর কি করছো এখানে করছো? তোমার কথা আমি শুনতে পাচ্ছি না, আর এইটা এখন রেকর্ড হচ্ছে কিনা আমি জানি না, আমি রেকর্ডটা পজ করে। ওকে, সো ওয়েলকাম ব্যাক। I think you are back. We can start with the next problem. Okay, so I think I'm loud and clear. The problem is a city having population of 12 lakhs required 180 mld water. If the required water demand is met through 24-hour pumping, the average rate of pumping water from the source would be option A 42.24 meter cube per second, option B is 2.08 meter cube per second, option C is 0.18 meter cube per second, and option D is 18,000 meter cube per second. This problem is pretty easy, I think. Are you there? If you are calculating, I hope you are back.
Yes, sir. Yes, sir.
Mhm. I will give you 2 minutes. This is straightforward problem. Later, some difficult problem will come. Both of you are attending regularly, I think, since 2 or 3 classes. I've seen it. Nothing, no problem. Mm, If you are not attending, also you will get the slides anyways. Some data in the problem may be excess. It is not like that you have to utilize all the data. Option B 2.08. Donish is telling. We will go with the calculations. So uh, this pretty straightforward calculation, I think. I will go with the answer. So here the population of 12 lakhs, it is not required because nowhere in the problem per capita term is mentioned. So only directly from the 18 mld of water, you will be able to get the solution. So 18 mld means 180 into 1000 cubic meter per day. That means 1 day means 24 into 360 seconds. So that means 2.0833 cubic meter per second. So here MLD doesn't mean all every time you will while converting into second, you will every time you will consider as 24, because here it is told categorically that the water demand is achieved through 24-hour pumping. So that's why we are assuming 24 hour per day. If it is achieved with, let's say, 20 hours pumping, then in the place of 24 we have to put 20, like that way. So option B is correct. Okay. So next problem is the water tariff structure for domestic connection in Bangalore is given as there are monthly consumption slabs in kiloliters, and there are unit rate of water in rupees per kiloliter. Okay, so you have to calculate the monthly consumption bill for a household consuming water of 32 kiloliters in a month. Option A is rupees 275, option B is 320, option C is 425, and option D is 550. So to solve the problem, I will not tell the answer. Let's see what you are calculating. Because there is a common mistake with which generally people do. I also, while solving that problem by not looking at the answer, I also solved it uh, wrongly. That's why I'll give you time to solve. Give you 2 to 3 minutes. There are slabs. Let me explain the slab basically. So from 0 to 8, the 0 to 8 kiloliter, the unit rate of water is 7 rupees per kiloliter. From 8 to 25, it is 11. From 25 to 50 kiloliters, it is 26 rupees per kiloliter. And above 50 kiloliters, it is 45 kiloliters. So the thing is that from zero above, so for zero, there is no cost basically. Once it start from point one onwards, like when it is greater than zero, up to 8. So 8 is included. Here 8 is not included. That is greater than 0 up to 25. So here 25 is included, but 8 is not included. That is above 8. Here 25 is not included. Above 25, but 50 is included. Up to 50. And here 50 is uh, not included. So if it is more than 50, then it is 45 rupees per kiloliter. So the slab is like this way. So if I say the problem is straightforward, you will calculate it in some way, and if I say it is not straightforward, you will calculate it in some other way. That is the thing. So in one way, telling that the problem is not straightforward, it is also giving you a hint. So Donis is calculating rupees 425. Okay. Uh, I'll give you a minute more, and then I'll go to the solution for Zobin to calculate. So I think if I don't know what is the wrong way of calculating the solution. So if you have calculated in the wrong way and you have not found out the answer in one of the options, then you would assume that it will be calculated in the other way. So I'll proceed with the solution. I'll also tell for the recording sake that what is the common mistake. So the thing is that the detailed solution is as follows. The water bill for 32 kiloliter consumption is 8 into rupees 7 plus 17 into rupees 11 plus 7 into rupees 26. That means rupees 56 plus 187 plus 182 equals to rupees 425. So Danesh has calculated correctly. Option C is 425. So what people commonly do mistake here is that it is 32 kiloliter. So it is in between 25 and 50. So they will directly multiply 26 with 32, and they will add a in whatever answer is given. I mean, I don't know whether it is coming in one of these answers or not. So this is the very common mistake. And but the thing is that it is not to be calculated like that way. So this type of water pricing has certain name. we will come into it later. So what is happening in this case? So they are telling that if you keep your consumption within this, so electric sometimes also electricity units which are expressed in kilowatt hours by the electricity boards. Also sometimes electricity pricing is also done like this. So they are telling that if you limit your consumption within 8, then your tariff will be less. If you consume more water, then your tariff will be more. If you consumption even more water, then your tariff will be more. So that's why this type of tariffs encourages people to utilize less amount of water. But the thing is that if the metering is done mm, on an family basis, for example, one family and 1 meter, if it is done like that way, then sometimes what happens that more people naturally needs more water than the less. For example, some family is of 10 people and some family, for example, is of 2 people. So 10 people will obviously need more water than the 2 people. So for example, 10 people is requiring 30 kiloliters of water, but 2 people is requiring your, for example, 24 kiloliters of water. Their pricing will be less for the nuclear family, but the large family, their pricing will be more. But here some injustice is being done, because if you consider in per capita basis, then this pricing structure may not be fair to the large family, because large family will obviously need more amount of water, right? But they will have to pay more tariffs, because the metering is done per family basis. So that's why sometimes to make this kind of tariff structure sustainable, one have to the water supply company or the municipality has to employ certain hybrid pricing structures. So every the what are these types of pricing structures, so we will actually come in subsequent MCQs. Okay, so let's go to the next portion. So here you have to match the correct description of the process with their name given in the columns below. I think this is pretty much common. You have done it earlier. I think pretty easily also you will be able to tell the answer. I am just telling it as a recap, because Ojim, he has not joined today, I think. So he asked a pretty good question on uh, paved area and non-paved area runoffs. So I just modified the problem which was discussed in last class to understand the concept in a bit detailed. So that's why I kept this MCQ, just a recap. Not MCQ. You have to match the columns. So here they are telling that some of the water evaporating from plants as well as land. In the left hand column it is written secondly as rainwater shipping through soil to reach groundwater. What is the terminology with respect to that? And the third one is that the overflow of excess rainwater to lower aligned areas. In the right hand side, it is stated as infiltration, surface runoff, and evapotranspiration. I will not spend much time in answering that. So the explanation is as follows. So evapotranspiration is defined as the sum of evaporation from the land surface plus the transpiration from the plant. Infiltration is the process of water entry into the soil through the earth's surface. If there are two subsurface zones, and from one zone to the other zone the water is going, then uh, with respect to the first zone the water is basically outfiltration. In case of the surface runoff, it is water from rain, snow melts, and or other sources that flows over the land surface and is a major component of the water cycle. Runoff that occurs on surfaces before reaching a channel is also called as overland flow. Okay, so the matching is pretty clear. The option one is evapotranspiration, where both evaporation and transpiration is occurring. Rainwater sweeping from soil to groundwater is infiltration in respect to the groundwater, and the overflow of excess rainwater to lower aligned areas is surface runoffs. Okay, so now we'll solve the problem, which is a bit modified than the previous one that we solved in the last class. So a 2,500 hectare sized town with 50% paved area or half paved area of 2500, that is 1250, I think. Yes. So holding that area is holding a population of 2 lakhs. That is total town is holding the population. Huh? Paved area means that is cemented area. So population may stay in the cemented area, maybe may not stay in the cemented area. That doesn't matter. Withdraws water from a lake of volume 1500 meter cube and from groundwater if needed. Now we have to estimate the urban runoff percentage contributions with respect to the paved versus non-paved. So what is the percentage runoff of the paved area? What is the you have to calculate the total runoff, and you have to calculate how much percentage is the paved, how much percentage is the non-paved generated within the town for lake recharge, because lake recharge is done from the runoff generated, that is generated in the town individually from paved and non-paved you have to calculate, and groundwater infiltration you have to calculate. Same data as the previous problem. The annual rainfall is given as 1000 millimeter. Here it was given as 500 millimeter in the last class. The annual infiltration is 220 millimeter from non-paved area. The annual evaporation from paved area is 180 millimeter. Annual evapotranspiration from the non-paved area is 250 millimeter. I already told that why and yes, 1 hectare is 10,000 square meter is the hint for solving the problem. Why I already told that from the non-paved area, the vegetation is responsible for the transpiration and evaporation occurs from the soil, and from the non-paved area, there is almost no transpiration and almost no infiltration. So infiltration mostly occurred in these cases. Here the infiltration is negligible and the transpiration is negligible. So mostly evaporation occurs from the paved area, and both evapotranspiration and infiltrations occur from the non-paved area. So here you don't have to go to the water matrix. Just from the given data, we have to calculate the individual that is called runoff rates. Individual percentage contribution of the runoff rates you have to calculate. So I think okay, Donesh has given the previous answer. I think you have given it correct. Hmm. Okay, this is just for solving the problem. Conceptual, it was kind of recap. So here I think should I go with the solution or should I wait? I'll just see 132 132. Yes, last problem you have answered it correctly. So this problem should I okay. So I'll move into the solution. Uh, so the given data are the total town area as 2,500 hectares. That means this much meter square. Half of it is the 50% of it is the paved area, which is also equals to the non-paved area, but these are separate areas. And annual rainfall in individual areas, that is in paved area it is this much amount of meter cube, and in non-paved area also it is this much amount of meter cube. So total is basically 2500 into 1000 millimeter. So I think it is clear. Then the annual infiltration from the paved non-paved area is given in millimeter terms as 220 millimeter. So if you multiply it with the total non-paved area, then you will get the groundwater recharge in meter cube unit. Annual evaporation from paved area is given in millimeter as 180 millimeter. If you multiply it, convert it to meter and multiply it with the total paved area, which is same as the non-paved area, then you will get the annual evaporation from the paved area in meter cube unit. And annual evapotranspiration from the non-paved area, it is given in the question in millimeters as 250 millimeter. If you multiply it with the total non-paved area, which is same as the paved area in our case, it will be 31 lakhs and 25,000 meter cube. So up to this thing, it was similar to the last quarter. Only the annual rainfall data is a bit different. The all the other data are same that we as we discussed in our last class. So now the total amount of runoff from the paved area will be rainfall in paved area minus evaporation from the paved area. It is a bit different. So the rainfall we calculated in the paved area is 1 lakhs and 25 1 crores and 25 lakhs meter cube minus only the evaporation that is occurring from the paved area in meter cube, that comes out to be 1 lakhs and 1 crores and 2.5 lakhs of meter cube. And total so if you convert it into megaliters per day unit, then you multiply it with 1000 and divide with 365, it will be liters per day divided by 10 to the power 6. That comes out approximately 8.1 mlpd or million liters per day. Okay, so amount of runoff from the non-paved area is rainfall in non-paved area minus infiltration plus evapotranspiration from the non-paved area. So in paved area only evaporation is occurring, non-paved area both infiltration and evapotranspiration is occurring. The values are rainfall and value is same. In some questions, if the percentage of area are different, then the rainfall value may be different. In our case, it is same. And the infiltration value, the evapotranspiration value that we put from what we have calculated from the non-paved area. By summing them up, it comes out to be 58 lakhs and 75,000 meter cube, which gets subtracted from the total annual rainfall from the non-paved area, and it comes out to be 66 lakhs 25,000 meter cube annually. Now, if you convert it to megaliters per day unit, then this will be the conversion factor. Okay, so it comes out to be 18 mlpd. So there are two runoffs. If you just separate the two runoffs from the paved area and non-paved area, then it is 28 mlpd and 18 mlpd. If you uh, want to take the lake water recharge that is that is being done total from the paved area and non-paved area runoffs, then it comes out to be 28 plus 18 equals to 46. Then the percentage contributions will be respectively 28 by 46 into 100, that is 61%, and another will be 39.1%, that is basically 18 divided by 46 into 100. So these are the individual contributions. And groundwater is occurring only from the infiltration, that is this one. So if it is stated in the question that paved area runoff is going somewhere else, non-paved area runoff is going somewhere else, or only one is responsible for recharging the lake, either paved area or non-paved area, then you have to consider the individual runoffs. But in our last problem, it was stated as the total runoff. So we considered the total infiltration area, sorry, total your runoffs to recharge the lake water. Okay. So I think it is clear. Any doubts? Okay. So this was just to clarify the individual runoff concept. Now the next MCQ for you is based on the water tariffs. So water tariffs should be designed for ensuring water and sanitation services at option A price that return significant profit for water utilities and service providers. Option B is price affordable for all class of consumers. Option C is subsidized class for all class of consumers, and option D is no cost for poor class of consumers. So what is the ideal way for designing water tariff that ensures water and sanitation services? I remember that Sarah clarified these concepts very well in the interactive sessions that occurs last Thursday. So you should be able to answer these questions. Option B, price affordable for all class of consumers. Don is telling. Okay. So price affordable, not subsidized. So yes, option B, you have given it correctly, answered it correctly. Price affordable for all class of consumers, because water and sanitation services are something very basic, and the resources are uh, owned by public agencies, just like municipalities or government or central or state government. So that's why the way they should design the tariffs, that must be affordable to all class of the consumers. Okay. So the next MCQ is, which of the tariff models provide consistent and reliable revenue? Option A is increasing block tariff. Option B is uniform tariff. Option C is flat rate tariff, and option D is decreasing block tariff. So the problem we solved one or two problem earlier, where actually for increasing uh, that is called for increasing water consumption, uh, the families are charged with higher rates of water. So that is basically called as the increasing block tariff. But here the question is a bit different. It may be option A also. Which of the tariff models provide consistent and reliable revenue to the agency who is supplying the water? Uh, Option C, Donish is telling. I think it is correct option. So yes, flat rate tariff is the correct answer. Because, for example, sometimes it may so happen that most of the people or most of the consumer to whom the water supplying agency is supplying the water is of lower middle class or poor income category. So then they may not be able to afford prices for, I mean, for any kind of water consumption. But if you just give free services to them, then that may not generate reliable revenue for the agency who is supplying the water. So that's why there must be a minimum tariff, or there must be a flat the tariff. If you keep the rate of tariff as constant, you will actually later see what is the flat rate type is. If you keep the rate of the tariff as flat, that is constant with respect to the water consumption, that will generate a reliable revenue for the agency that is giving the service to the consumer, that is supplying the water to the consumer. Okay, so the next MCQ is concept of sustainable water pricing is important for which of the following? Option A is conservation of water as a resource. Option B is to recover cost of services. Option C is to improve water services standard. Option D is all of the above. We have seen water audit, which is related only with the water resource and not with the pricing or cost aspects of the water. Uh, that is the concept of water audit. But what is the concept of water pricing and also sustainable water pricing? So it is related with which one of the following? You have we have discussed the term sustainable a lot in the last classes, in the previous classes. So, and also Sad has discussed in his lectures. So I think you'll be able to answer this. Don is telling option D, all of the above, and I think it is again correct only. Yes. So option D is the correct answer. Why sustainable? Why it is important? Because the water pricing must be sustainable. So from environmental conservation point of view, the water resources must be available for the future generation. The whatever for the agency whoever is supplying the water, from them also the I mean profit must be there, so that they are or maybe the cost may be recovered by government subsidy and all, so that whatever cost incurred by them, that is fully recovered. And also the standard of the water, that is the quality, that is the parameters of the water that is being supplied, so that is also important aspect. So for mitigation of diseases, waterborne diseases and everything, and the quality of health of the people is important. Sorry. From the government agency point of view, so that's why all the three aspects are important in terms of the sorry, concept of the sustainable water pricing. Okay. So next MCQ is water tariffs need to be set and from time to time revisited and adopted for which one of the following? Option A is generating revenues to cover operation and maintenance cost. Option B is for necessary infrastructure development and expansion. Neither A and B, both A and B. Jonas is telling both A and B. Water tariffs. Okay. So we'll see the answer. Jovin. Jovin is also telling D. So yes, you have guessed it correctly. I don't think this needs much explanation. So option D, that is both A and B, is correct. Okay. So next MCQ is you have to identify the correct statement about fixed charge or flat rate model of water tariff. So uh, the models actually we later some graphs will come into the picture. With the help of the graph, actually it will be easier for you to understand the concept of pricing. So here you have to identify the correct statement. Statement 1 is under a flat rate tariff, consumers' monthly water bill is independent of volume consumed. And statement 2 is it is not possible to implement flat rate model without metering all the consumers. So we have told that some per capita metering is a good way of pricing the water, but it is not economically affordable for the agency who is performing the who is installing those meters, because it will incur a large cost. So that's why the metering is done on a individual family basis or individual uh, household basis. But sometimes if it is a large household, then the increasing block model will not be so justified for them. In that case, flat rate model, fixed charge model will be good. But sometimes people use, as Sad told in his lecture, sometimes there are luxurious uses of water. So some people just uses water in such a way that is not required at all. So in that case, the increased block model is justified as compared to the flat rate model. So there is a basically a trade-off. So one has to uh, do a survey of the income category of people that is present in such a in an area. So accordingly, one have to apply either these kinds of model or increasing block model, or one have to combine use a hybrid model kind of thing. So we will look into that. So here you have to identify either statement 1 is correct or 2 is correct, or both are correct or none are correct. So both are telling option A is as the statement 1 is correct and statement 2 is incorrect. And I think it is correct answer. Flat rate tariff here, the individual people, whatever the water they are consuming, so it is independent of that. There is a minimum service charge for the flat rate model, and also it remains constant with respect to the volume of water that is getting consumed. But the flat rate model is possible to implement without metering all the consumers, because the metering is required for the calculating the volumetric consumption only. If the volumetric consumption is not affecting the tariff, then there is actually no need of the metering for implementation of the flat rate model. So that's why option A is correct. Okay, so we'll move on to the next MCQ. The simplest way to price water based on customers' level of usage is uniform tariff model, flat rate model, increasing block tariff model, and decreasing block tariff model. I think all of the four concepts are pretty much clear to you until now. Till now, so Ganesh is telling option A, uniform tariff model, based on the customer's level. So here basically volumetric consumption is taken into picture while calculating the price of water that is charged to the consumer. So I think it is correct only, because here you are not considering the income level of the people. Whatever people are utilizing, uh, only based on that, the amount of water is basically the amount of water you spend, the more you have to pay for it. Simple. So there is no block for that. So it is actually uniform type model is suitable for families or large families basically, but it is not suitable or justifiable for luxurious use of water, because there will be people of high income generation, they high income category, they will use the water for their luxurious uses, which will adversely affect the water availability of the future generations. Okay, so next MCQ is, as per the design principle of increasing block tariff model on which we just solved one problem, an ideal progressive tariff structure includes low price block corresponding to essential minimum consumption, a lifeline block ensuring free water up to basic minimum consumption. Option C is high priced block aiming for generating profit for the utility. And option D is all of the above. So what is the design principle of the increasing block tariff model? You have to keep in mind that. What must be the ideal way or everything you don't have to consider. Just these three terms are important. Design principle, increasing block tariff model, and ideal progressive tariff structures. This is actually same as the design principle. So what is the ideal design principle consists which one of the following or all of them. Donesh is telling option D. Uh, Jovin,
Yes, sir.
I am not able to hear you. You can, if you have any doubt, you can type in the chat box or you can just type the answer. Just it is based on the what is increasing block tariff model basically. One has not to uh, actually there is no consideration of profit that is uh, that is to be generated for the utility. So the model doesn't consider that. So there is no essential minimum consumption. So you can keep the minimum value as zero, or you can just keep a marginal value for your service charge. So the model there is no consideration of that. So only increasing block. Sorry, this doesn't consider. So there is no basic minimum consumption value. So only uh, with increasing water usage, the price of the water or the block of the water tariff increases. So that generally means lower consumption implies lower price of the water. So that's why low price block will correspond to essential minimum consumption in this case. Okay, so all of the above will not be here, not be the case here, because this will never come into the picture. High price block aiming for generating profit for utility, because there is no profit consideration for the model, block trading model. So though in real case, real scenario, it is there, but the block trading model doesn't talk about that. So that's why option A will be the correct answer. Higher price block corresponds to the higher consumptions, and lower price block correspond to the essential minimum consumption. And also you can keep the basic consumption as zero, and also you can fix a value for, or you can charge a price for a certain consumption of your water. Actually, we will understand. I we are almost at the end, but I will. So should we continue or what? Just wait. Let me see. Uh, okay, some other MCQs are there. Okay, so some concepts are there based on certain graphs with which you will be it will be easier for you to understand the different types of models. So those MCQs actually we will cover in the later classes, but there are few more, one or two MCQs just based on the terminology of the model, not some pictorial understanding or something. So those one or two MCQs actually we will cover. I am requesting you to bear with me for 5 more minutes. So for certain for those one or two MCQs. So the latter understanding, the pictorial understanding will come into the later classes. So which one of the following model often penalizes poor but larger families or larger households which shared connections, or with it will be with actually shared connections. So uh, we discussed it already. So for larger families, there will be a larger water consumption, but certain one kind of model is not fair for them. So we discussed it while solving the problem. Uh, Anyone? Uniform tariff, flat rate, increasing block tariff, and two-part model. And all of these models, you now have a fair idea about them, but still we will have certain clarity on it when we will solve certain graphical MCQs based on this model. But still, please bear with me for 3 to 4 minutes more. Okay, we'll go to the answer. So as you discussed earlier, so it will be increasing block tariff model, because the larger families will have obviously larger uh, water consumption, but as there is no provision for measuring the per capita consumption, there is no provision for per capita water metering. There is only 1 meter for family, so that's why they will be charged with higher tariff. So that's why the increasing block tariff model is not justifiable for poor but large family. They actually penalizes them, or large households with share connection, though their individual per capita consumption may be lower than them who are utilizing the water for certain luxurious purposes, like rich families or like that. But rich families also can use the water resource responsibly. So then the increasing block tariff model is justified for them. But for large families, it is actually penalizing to them. Okay. So I think, okay, one or two more MCQs are there. Uh, so two-part tariff models can be described as both fixed charge and variable charge depending on volume of the water consumed. Option B is a combination of uniform tariff model and increasing block tariff model. Option C is charging part of consumers while providing free water to the rest of the consumers. And option D is each unit of consumption charge at a different rate for poor and affluent class people. So I'll directly go to the answer. I will not take your much time. So basically, what two parts model considers, it is described as follows, where both fixed charge and the variable charge, depending on the volume of the water consumed, are described. So this is basically the two-part study model. Okay. So next problem onwards actually comes the graphical understanding of the different pricing methodology or the water tariffs. So that we will discuss in our next class. So any doubt regarding this, if you are having, you can ask questions, or we'll close the session after a couple of minutes. Jobin, I am not able to hear you. I think can you say something?
No doubt, sir. No doubt, sir.
Okay, okay. So after a minute or so, we'll close the session. Thank you, Tanesh. Good evening.
Okay, sir. Thank you, sir.
Okay.